We are on building the unit circle in the first quadrant. This should be the second page of the PDF file that has reference angles and building the unit circle as a title. So I'm going to review a few things with you guys first, including some things that we had learned in the previous lessons. So first of all, sine, we had said with a unit circle having a radius of 1 is associated with y, and cosine is associated with x. Tangent was the ratio of y over x. So I'm going to, and you see the chart over on the right that has the angle measures. I'm going to ask that you guys start by go ahead and figure out what the radian equivalents of those angle measures are. So we should have gotten 0, 30 is the same thing as pi over 6, 45 is pi over 4, and 60 is pi over 3. And 90 degrees, pi over 2. Okay, so I'm going to first start talking to you guys about quadrantal angles, and what those are when we're taking a look at the unit circle, you have 4 angles that fall on the x and y axis, those coordinate points right there, 0 degrees, 90 degrees, 180, and then 270 degrees, as well as 360. So if the unit circle has a radius of 1, then this coordinate point would be 1, 0, meaning that cosine being x, cosine at 0 is 1, sine at 0 is 0. At 90 degrees, you have the coordinate point 0, 1. Cosine being x, cosine of 90 is 0. Sine being y, sine of 90 is 1. We can do the same thing at 180, and then once again at 270, and then it repeats after that. So for your 0 degree column, actually what I'm going to have you do is fill out what do you think sine, cosine, and tangent are for 90 degrees. So at 90 degrees, I have the coordinate point 0, 1. So sine being associated with y, cosine with x, and tangent with y over x. The y value at 90 degrees is 1. The cosine value is the x value, which is 0. And tangent is y over x, where when we're trying to divide by 0, we can't. So that tangent at 90 is undefined. So I did that one with you guys. Actually, can you go ahead and try doing 0 at 0 degrees? So we should have gotten 0, 1, and 0. Now the question is, how do I find it for the other angles at pi over 6, at pi over 4, and at pi over 3? So what we're going to do is refer to the special right triangles that you see at the bottom. If I can have you guys have 3 different colors out. The angle measure that we first will work with is 60 degrees. So we're going to picture that this is the radius of the unit circle, the hypotenuse is, and then the legs form a 90 degree angle. And if we trace that same triangle within the unit circle, we see angle A is in fact 60 degrees. Okay, so now we're going to try to figure out what that coordinate point is associated with H. So since we're used to certain ratios for special right triangles, I'm going to go ahead and use those ratios. So the values should be proportional. So instead of making the radius 1 here, I'm just going to use those values that we're familiar with 2, 1, and radical 3 from special right triangles. So from here, if I'm trying to find sine of 60 degrees, since I'm positioned at theta being 60 degrees, I would do opposite over hypotenuse and get radical 3 over 2. And then think, okay, well, sine is associated with y. So the y coordinate at 60 degrees should be radical 3 over 2. And then on the table of values, if I go to sine and 60 degrees, so let me highlight where we're at. Sine at 60 degrees. Okay, so that's where we're at. Sine at 60 degrees would be radical 3 over 2. So now go ahead and do cosine. Cosine of 60 would be adjacent over hypotenuse, which is 1/2. And cosine is associated with x. So we go to the x-coordinate, fill out 1/2, go to the x cosine of 60 on the table, fill out 1/2. And then I'm going to erase this and then talk to you guys about tangent. Tangent of 60 would be the ratio of y over x. So if I find y, I see that it's radical 3 over 2, and x is 1/2 from the coordinate point, either from the table of values or the coordinate point. If I multiply top and bottom by 2, what I'm effectively doing is multiplying by 2 over 2. But the nice thing is that if I multiply the top fraction by 2, it'll eliminate the fractions, so that I get tangent of 60 is radical 3 over 1. So under tangent of 60 degrees, we'll go ahead and write radical 3. Since we already know the quadrantal coordinate points, this being 1, 0, and 0, 1, I'm also going to fill that out on the quadrant 1. So we're looking at what the unit circle looks like only in quadrant 1 here. And now we're going to make the switch of colors to blue to find out what happens when we have a 45, 45, 90 triangle within the unit circle and what that means. So again, switching the ratios so that they're more familiar to you, we'll go ahead and make this radical 2, 1, and 1. So can I see what you guys remember about sine of 45 degrees? Okay, sine is opposite over hypotenuse. We can't have a radical on the bottom, so we'll rationalize and get rad 2 over 2. So sine is the y value. So under the y value for 45 degrees, what I'm going to do is fill that out because there's a missing underline. The sine is the y value. We're going to go ahead and fill out rad 2 over 2 in the table and on the unit circle. Go ahead and do cosine. You should have noticed that cosine of 45 adjacent over hypotenuse gives you the same value. So cosine of 45 degrees is the same as sine of 45 degrees, and that makes sense. The legs of that triangle are congruent to each other. And then so if tangent is y over x, what happens when you put rad 2 over 2 over rad 2 over 2? Well, you get the value, something divided by itself is 1. And then our last triangle I'm going to do in green, and that's with an angle measure of 30 degrees or pi over 6. Trace that color in the first quadrant as well. Okay, so then you have, again, the ratio being 2 here, 1, radical 3. Okay, can I have you go ahead and find sine of 30 degrees? And when you do sine of 30 degrees, you guys should have gone radical sine of 30 degrees being, oh, you know what, you guys, I should have made this 1. So going from the hypotenuse to the short leg, it's 1, and then the medium leg is radical 3. I apologize for that. So sine of 30 degrees should be opposite over hypotenuse, giving us 1/2. So go ahead and fill out 1/2 for the y value of the coordinate, as well as the sine of 30 degrees on the table of values. Cosine would be adjacent, which would give me radical 3 over 2, as well as the x coordinate of that angle measure at 30 degrees is radical 3 over 2. So that completes how to build the unit circle for those 3 values, 3 trig values. Oh, it looks like I forgot tangent as well. So for tangent of 30 degrees, we're going to think of tangent as y over x. So with tangent, you have, let's go ahead and do this together, the y value being 1/2 and the x value being radical 3 over 2. If I multiply top and bottom of that by 2, what happens is that I end up with 1 over radical 3. When I try to rationalize that, I get rad 3 over 3. So please go ahead and fill out the table of values with tangent of 30 degrees as well. So the goal is for you guys to remember this and not have to do the triangle each time. I wanted to show you guys the triangle to make the link between what we had learned before and how that translates to the unit circle. What we're going to do after this is build the entire unit circle. You're going to watch a video on fingernometry, which is a easy technique to remember the first quadrant, and then I'll talk a little bit about the patterns that you should have picked up on that video so that you eventually take what you remember in the first quadrant and then translate it to the other three quadrants.